If you've been paying attention here on Crash Course Geography, you know that pretty much everything has an intricate story with twists and turns. Not just bananas. And the very device you use to watch this video is no exception. Whether it's a computer or a phone, our devices have complex stories that span the globe, from the Democratic Republic of the Congo to China to the United States. Like, take a laptop. The battery inside that machine typically requires materials like lithium to provide the current and cobalt to help stabilize the charge. But unlike bananas, lithium and cobalt don't grow on trees. And mineral extraction, or the removal of rocks and minerals from the Earth's crust, is one of those human activities that touches all aspects of geography. I'm Alize Carrere, and this is Crash Course Geography. Today, our story begins deep within the Earth. Primary economic activities that extract things from the Earth, like mining, alter the physical geography of the planet dramatically. Like when mines below the surface cave in, or when deep pits are dug for surface mines, or when entire mountains are leveled. All of this can leave tremendous scars on the Earth. And yet entire regions can depend on what we can extract out of the Earth, both land and sea. So mineral extraction is another one of those topics where the line between physical and human geography is blurred. And different types of geographers can study different facets of mining. For instance, geomorphologists study how landforms are made, and along with geologists can help understand what types of minerals we might find in different places. They use their understanding of physical processes to estimate how much of a material is in reserve, or the estimated supply of a mineral resource. And environmental geographers look at human interactions with the environment and how that changes across space. So both geomorphologists and environmental geographers might study electronic devices like computers because of the minerals they use, like cobalt and lithium. From where we get those minerals to how the profit involved in mining them affects the politics or culture of a region. As any type of geographer, we're always looking for patterns and trying to answer why something is here and not there. And that's helped us figure out some general principles of mining landscapes, which also helps us understand where to look for different types of minerals. For one, we can't create mining towns just anywhere. As materials were spewed from volcanoes or buried in ancient lakes and oceans, compressed over time and then moved through geologic processes, they decayed and transformed. And those and other ancient tectonic processes have left all these resources distributed in particular patterns throughout the Earth. Like how fossil fuels like coal and oil, or deposits like uranium aren't under any old stretch of land. Or rare earth elements like cerium, lanthanum, and yttrium, which show up in lots of different places but only in trace amounts and are extremely difficult and expensive to extract. Which is why they're rare. Fuel resources like coal and oil, and non-fuel mineral resources like rare earth elements, or things like iron or limestone, are called non-renewable resources, because the resource can't renew in a human's lifetime. They renew on large geologic timeframes that take millions of years. So non-renewable resources are essentially limited in supply. And because they're also difficult to extract, they're very expensive. And those physical factors create other social patterns in mining areas, like economic patterns. Activities that extract stuff from the Earth rarely generate as much wealth as when the raw materials are taken and refined. So as geographers, when we think about mining, we realize that mining provides low-wage, risky work, often in isolated areas. But those areas often don't have a lot of other job opportunities. And mining has a huge impact on the land. Like, take any surface mining operation, with large pits where water and the toxic chemicals used to separate minerals pool. Removing the overburden, or the soil and vegetation in that location, means that when the mining is done, there will not be any soil there for generations. The communities where these mines are located often don't have the resources to fix these environments on their own. So they get stuck in an economic pattern which further limits the wealth and productivity that might move into these areas in the future. Now, to tell the story of cobalt and lithium and computers, we have to first mine for different elements entirely. Nickel metal hydride batteries contain the rare earth element lanthanum, and they used to be a much more common portable battery in laptops and phones and electric cars. But nickel metal hydride batteries can be difficult to charge properly, and are large and heavy. Technologies like phones and laptops eventually transitioned to using lithium-ion batteries, which are lighter and are easier to charge. There's also an economic advantage to using technologies that rely less on rare earth elements. The largest rare earth element reserves are located in China, which can be a politically complicated trading partner. That's where lithium and cobalt step in. Lithium has increasingly been used to make batteries because it easily conducts a current, it's light, and its structure makes it possible to reset its ions and electrons through recharging, especially when used with cobalt. This makes this combo very useful in batteries for things like phones, electric cars, and computers. Lithium and cobalt are also strategic mineral resources, which means they're critical to the national security or to the strength of the economy. But that doesn't mean cobalt and lithium are a no-strings-attached alternative. What's now called the Democratic Republic of the Congo supplies about 70% of the world's cobalt. But the cobalt landscapes, both social and physical, have had huge human and economic impacts on the DRC, even perpetuating civil war. If we zoom out, the Democratic Republic of the Congo is a country full of water, good soil, and vegetation. It's also part of the geologic movement of the African Rift region, and there are rich soils, tropical rainforests, and deposits of valuable minerals like tin and tungsten, and cobalt. Back in the scramble for Africa when Europe was dividing up the continent, the DRC, as a resource-rich place, was highly coveted by colonizers. And this jump-started political unrest and suffering that's still going on. In 1960, when the Democratic Republic of the Congo gained independence from Belgium, this resource-rich country had a population that had been denied human rights like education for generations, leaving the population with a mostly primary economy. By 1996, war erupted in the DRC and is considered by the International Rescue Committee as the deadliest war since World War II. Even in 2022, regional conflicts are ongoing, and the war there has layers of tensions, like ethnic conflicts and distrust between villages and the central government, that make it hard to broker a lasting peace. Some of the fighting is also tied to access to land, especially land containing minerals. Because the process to legally mine in DRC is time-consuming and burdensome, many mines are illegal, and that means there's often not a lot of oversight over how the land is used or how the workers are being treated. These mines become sites of abuse of those working there, and mine profits can end up funding the militias that defend the territory from outsiders and the government. The miners themselves tend to do hard work with hand tools, and miners, their families, and their communities are exposed to a range of toxic materials, adding poor health to the list of troubles the people of DRC face. Yet Congolese people still come to work in these mines because there are few ways to earn a living, though those who work in the small, unregulated mines still don't make a lot of money. By not paying much for the labor, it keeps the price of cobalt low. So as the world comes to understand the cost of mining on the mining communities themselves, there is mounting pressure put on governments and corporations to stop using unregulated minerals. This might help to ensure some of the mining wealth stays in the mining communities and to stop the use of child labor in DRC mines. There's also a debate between international human rights advocates, mining communities, and international corporations over whether to classify cobalt from the DRC as a conflict mineral, which are minerals that create and perpetuate conflict and war. And if cobalt was a conflict mineral, suppliers would have to prove that cobalt came from mines not funding militant groups and perpetuating the conflict in the DRC. Which sounds great, but this move is controversial on many levels, including the lack of income miners face when the world stops buying those minerals, and the complex relationship between the mining areas and the elected government. And some estimates put cobalt production at 70% of the DRC's economic output, which means if businesses can't legally use DRC cobalt, it could upend the country's economy. So it really isn't enough to have the stuff, and so far we've only covered the front end of mining. The DRC has a lot of mineral wealth, but its complicated colonial and political history and a legacy of underinvestment in the country and its people create a mining economy that leaves people trapped in poverty. But the landscapes related to mining also can include electronic waste, or e-waste landscapes. These are places where electronics that are no longer useful are stored. Some are refurbished and reused, some might be recycled, and some end up in landfills. Much of the e-waste in the world finds its way to places like Ghana or Guiu, China, where things like toxic leaching impact places with the least amount of money to pay for cleaning the waste up. This is an example of an externality, or hidden cost, that isn't included when we consider what an item costs to the consumer. The cost of cleaning up the waste of a product, like e-waste, isn't included in the cost of the item. So that means no one is really paid to clean that mess up, and those costs are often passed on to low-income communities and communities of color. But humans are amazingly creative individuals, and people are trying to invent ways to minimize the impacts. Engineers and researchers are trying all sorts of ways to make extracting rare earth elements and lithium from spent materials easier. There are experiments on using everything from fungi to chemically stable ionic liquids to recover metals already in our devices. But one of the biggest challenges these processes will have to overcome is how to do them on large scales. We also know there's a reserve of metals in our landfills, but we don't have processes that are affordable enough to use them. Though scientists hope when reasonable methods are developed, we might mine landfills for these metals. Until then, resources in landfills are considered economically depleted because it costs more than the resource is worth to extract it. So no matter where we are or what we're doing, we are embedded in a landscape. It's the way our surroundings are shaped by our cultural symbols, the patterns of vegetation, sunlight, and precipitation in a place, the way boundaries create sharp contrasts between areas that otherwise might look the same, or the way our economic activities create particular scenes. Primary production like mineral extraction creates complex landscapes of poverty, environmental destruction, and the potential for war and conflict. But without these materials, we can't create the economies we've designed. And while there are efforts to innovate and create new ways of using resources with fewer ecological and economic impacts, the people who work in extractive industries often don't get a say in those changes in policies. How we use resources has implications, not just for our personal budgets, but in ways that also connect us with people half a world away. Many maps and borders represent modern geopolitical divisions that have often been decided without the consultation, permission, or recognition of the land's original inhabitants. Many geographical place names also don't reflect the indigenous or aboriginal people's languages. So we at Crash Course want to acknowledge these people's traditional and ongoing relationship with that land and all the physical and human geographical elements of it. We encourage you to learn about the history of the place you call home through resources like nativeland.ca and by engaging with your local indigenous and aboriginal nations through the websites and resources they provide. Thanks for watching this episode of Crash Course Geography, which was filmed at the Team Sandoval Pierce studio and was made with the help of all these nice people. If you want to help keep Crash Course free for everyone forever, you can join our community on Patreon.